Now let's quickly zoom in to HSRP. Stands for Hot Standby Router Protocol. Cisco proprietary, as I alluded to earlier. It allows multiple routers to appear as one by assigning a virtual IP and a matching MAC address. HSRP elects one active router to support data traffic from the endpoints at any given point in time, while the standby routers wait for the active router to fail. So what that means is, let's say if you had 4 routers that are participating in HSRP, only one could be active at any given point in time. The rest will be in standby mode, waiting for the active to go away. There are 2 versions of HSRP, version 1 and version 2. Now, version 2 is better and enhanced compared to version 1. And one thing that I want to let you know is these versions are not backwards compatible. So if you're in version 2, then make sure all the devices that are participating in that HSRP group are part of the same version. Otherwise, you're going to have stability issues and your HSRP is not going to work. HSRP version 2 communicates via multicast address 224.00.102 over UDP port 1985. It uses hello packets to talk to other HSRP enabled routers. Default hello timer is 3 seconds and the hold time is 10 seconds. Typically, the hold time is 3 times the default hello. And if you want to do HSRP load balancing, it can be achieved. You actually have to create multiple HSRP groups. Now, if this last point doesn't make a lot of sense to you right now, it will as I continue building on this. So we'll quickly jump on a CLI to do this configuration, and what I'll show you on the CLI is Bob's PC and Customer Edge 1 and Customer Edge 2 routers, and we'll go ahead and configure HSRP on our devices on CE1 and CE2 to show you how that impacts Bob. So the first thing we're going to do when we do our configuration is we're going to assign HSRP group and virtual IP, and then mirror the config on both default gateway routers. We'll then assign CE1 higher priority so it becomes active and CE2 becomes standby, and we'll also zoom into the HSRP group assignment. Now, if you see the virtual IP address on the screen here, it's 10.1.1.254. And the virtual MAC address in our case is 0000.0c9f.f001. Now, where does that come from? This is the default virtual MAC address on all the devices that use HSRP version 2. And as you can see, I've kind of given you a breakdown of how it looks. So all the elements in red, that signifies the Cisco vendor ID. 9F.F is the HSRP ID. And then the last portion, 001 in green, is the standby group number. Now, the standby group number changes based on the group that you choose. In our example here, we're going to choose group number 1, so it's going to match exactly what you see here. But if you were using group 2, then the last digit of the MAC address will switch to 002 instead of 1, and so on and so forth. Now that said, let's jump on CLI. So here I am on the CLI. One thing I want to show you on Bob's PC, if I do ipconfig/all, you'll clearly see that on Bob's PC, the IPv4 address is 10.1.1.99. The subnet mask is /24, and here's the default gateway, 10.1.1.254. Now, let's jump to CE1 and go ahead and configure our HSRP configuration. So if you recall, the first thing we're going to do is we're going to go to Fast Ethernet 00, and the HSRP configuration is done inside of the interface. So it's an interface level configuration. The first command we type in here is standby version 2. So that defines version 2 of HSRP for us. The next command we type in is standby 1, and this number 1 signifies the group number. And after that, we're going to type in our virtual IP that we want to specify. And what we want to do next is standby 1 priority 254. And finally, we want to type in standby 1 preempt. And what that does for us is preempt ensures that when this router goes down and comes back online, it will assume its role as the king of the hill, if you will. And the priority command, the higher the number, the better the priority. So priority is important because that's how you select or elect an active router versus a standby. So at this time on CE1, we're good to go. And let's go ahead and look at our configuration here. So we'll do show standby brief. And what you see here is that on a fast Ethernet 00, we belong to group 1. Our priority is 254. We are currently the active router. State is active. Active is local, which means us. We're local. Standby is unknown because we don't have the standby, the secondary router configured yet. And our virtual IP is 10.1.1.254. So let's go ahead and write our configuration on CE1. Now let's jump on to CE2 and quickly get this bad boy configured. So we'll do standby version 2, and we'll do standby 1 IP 10.1.1.254. And just like that, I now have HSRP configured on CE2. And let's quickly look at show standby brief. And let's take a look at that. And as you can see right now, our router on interface fast Ethernet 0/0, we belong to group 1, priority of 100, which is the default priority. We're in the state of speak. However, we went from speak to standby, which is good because we want CE2 to be standby, secondary, right? Active guy is 10.1.1.252. That is CE1, as you can see here in the diagram below. And standby is unknown right now because I typed in this command before the status change. So we'll redo this command and you'll see this is going to change. And the virtual IP is the IP defined in this diagram here. Now let's go ahead and type in this command again. And as you can see, standby is local, which means we're the standby device right now. And now let's go back to CE1 and see how that looks. And sure enough, now CE1 shows that router 2, CE2, is the standby. Now that said, let's go to Bob and do a continuous ping, and we'll do a ping to 109.10.1.99, which happens to be, as you can see on this diagram here, some public IP address that we're pinging. So this right here is a testament that our connectivity is working end to end because Bob is able to access this public IP on the internet. Now that said, let's go ahead and simulate an outage and bring down CE1 because I want to show how Bob's traffic will automatically switch over to the secondary router. Bob's traffic is currently going through CE1 to get to this 109 public IP, but when CE1 goes down, it should automatically redirect traffic over CE2 to access the public IP. So let's go ahead and do that. And also keep an eye on Bob's PC to the left. The continuous ping is going fine. So we're going to go to interface fast Ethernet 00 on CE1 and simulate an outage by typing in a shut command. Now, watch what happened on Bob's PC. As you can see, we missed a couple of pings, which means we lost a couple of packets as we switched. Now, it's not too bad, but we still lost a couple of packets. We can tweak timers to make that better for us. But in this example, to keep things simple, I'm going to go ahead and continue rolling. Now let's go ahead and bring that interface back up. And if you guys remember, we have a preempt command, which means our primary router should automatically assume its primary role momentarily here. And as you can see, Bob's PC is struggling. It's able to send a packet and then it loses a packet and then it sends a packet again and loses a packet. This is all due to reconvergence that the network is currently experiencing because of the failures that we just had. So as you can see, we still are dealing with convergence issues. And finally, Bob is good to go now because now the traffic is once again going through CE1 as primary. And as you can see, we lost a ton of packets when that happened. In reality, we would want to tweak these timers down to make the convergence faster. Here's a reference to the commands I typed on these routers. You can keep this in your back pocket as you try to replicate this in your lab. Now, a couple of additional pointers. Priority, like I said, in HSRP, election of an active and standby. HSRP router is based on priority. Priority can be defined within the range of 1 through 255. Default priority is 100. Next, preempt. Once again, when this option is enabled on the active HSRP router, when it comes back online, it assumes its primary role. And if you don't have that configured, then if the primary device went down and it came back online, it will never assume its primary role. It will always stay secondary. And finally, timers. Default timers can be changed from seconds to milliseconds, as I alluded to earlier. And one quick tip is we can create another HSRP group for load balancing by creating a VLAN and subnet. Now let me explain what I mean by that. So this is for you to do in your lab environment. And if you run into any issues, feel free to share your thoughts in the comments below. You see, when we have multiple workstations, so we got Bob up here and we got Dan at the bottom here. If we don't do load balancing, both Dan and Bob will always go through this guy, the CE1. And then the traffic will go down this way. Now, it's okay if it's just two PCs, Bob and Dan, but imagine if you had hundreds of PCs on the blue VLAN and hundreds of PCs on the red VLAN. You wouldn't want all of them to go through a single network point because then your CE1 will become a choking point. So in an ideal world, what you would want to do instead is you would want Bob's traffic to always take this path at the top, and you would want Dan's traffic to always take the path at the bottom through CE2 to access the wide area network. To do that, we're going to have to set up what's called traffic load balancing. And that's exactly what I'm showing here. In this case, what I'm showing is that Bob's PC has this IP, this is the default gateway it's using, the LAN subnet that it's part of, /24, and then the HSRP configuration that you would have to do on CE1 and CE2, respectively, as shown on the screen. And what you would want to do is create sub-interfaces on CE1 and CE2. And these links between CE1 and the switch and CE2 and the switch, the reason they're purple is because they're carrying multiple VLANs. They're carrying the red VLAN and they're carrying the blue VLAN. And when you combine red and blue, you get purple. You see what I did there? Pretty clever, huh? Now what we'll do is we'll make CE1 active HSRP router for blue VLAN and subnet via high priority. And the HSRP virtual IP that we'll configure here is 10.1.1.254. And what we'll do next is we'll set up another subnet completely separate from Bob's, and it's going to be 10.1.2.0/24. And you can see all the configuration here. We'll create separate sub-interfaces on CE1, CE2, create different groups, and configure them accordingly. And as you can see, what we're doing is we're basically making the CE1 active for blue VLAN, standby for the red VLAN, and we're making CE2 active for the red VLAN, standby for the blue VLAN. And that's pretty much it. Now, in the interest of time here, I'm going to skip the configuration part. But like I said, If you are configuring this in a lab and are running into issues, feel free to drop your thoughts in the comments below. Hope you enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.